The playground was my favorite part of going to the park as a kid. And my favorite swing? The slide, of course. Especially the ones at water parks, which were so much wavier. And thankfully, wavy, not edgy. Boy, that would have hurt. But if the slide was edgy, you know what it would look like? A frequency polygon. A frequency polygon is another way to present data in a graphical form. Let's learn how to draw one for this frequency distribution shown on the right here, which includes both the class intervals and boundaries. Since we need class boundaries for pictorial representations, that's a big green check on our to-do list. But hey, to make a frequency polygon, always remember to make two additional groups other than the ones you have already. One at the top and one at the bottom with the same class size. Here's our first additional group before the first interval with its respective boundary, of course. And here's our second additional group after the last interval along with its boundary. Since these two groups never existed in the first place, their frequencies would be 0. But why did we even do all of this? Well, hold your horses. You'll know why in a teeny tiny bit. For now, we'll go ahead and make a mid-class column. Come on now, you know how to fill this column up. Add both the limits of an interval or boundary and divide the result by 2. Great job. Now, we're getting somewhere. Columns, check. Now, it's plotting time. One way to draw a frequency polygon is with the help of our old friend, a histogram. We'll first draw a histogram from the frequency distribution which was given to us in the first place by taking class boundaries on the x-axis and frequencies on the y-axis. This is what our histogram should look like. Now, carefully mark a point in the middle of the roof of each bar. These points are actually representing the mid-class of each boundary. By doing this, we now have the class boundaries as well as the mid-classes on the x-axis. It's like hitting two birds with one stone. Not literally. The next step is simple. Just join all these dots and you'll get the graphical representation of the relation between each mid-class to their corresponding frequencies. But hey, we can't just stop here. A polygon is supposed to be a closed figure. So, we can't call this graph a frequency polygon just yet. This is where the additional groups with 0 frequencies, which we added in the first place, come into play. Plot the midpoints of these additional boundaries to close the polygon. Now that's what I call a perfect frequency polygon. There's one more way to draw a frequency polygon in which you don't have to make a histogram. Now how's that possible? Well, we can directly plot each mid-class on the x-axis and the frequency on the y-axis, choosing an appropriate scale. Then, we'll match each mid-class value against its respective frequency and plot a point. Now, join these points together and there we have it. We have ourselves another perfect frequency polygon. You can even color this closed figure if you want. Go crazy. Now, what if I tell you that there's another type of a frequency polygon? That's right. We call it a cumulative frequency polygon or simply an ogive. Stay tuned for our next video to learn how to plot just that.